Assalamu alaikum. I am RAOUF and today we will deal with the chapter from the 8th class, Exponents and Powers, from the maths section. If anyone after listening this lecture faces any problem regarding any question, he or she may contact me on my WhatsApp number that I have put here. So let's start our lecture, Exponents and Powers. Actually, we have learned in our previous class, that is 7th, that for example, if we take a number 10 raised to power 2, this 10, we were saying that this 10 is known as the base, and this we called as the exponent in class 7th. Okay, and this was pronounced as the 10 raised to power 2. Okay, but in this class we will deal with the new thing. The base will be same, for example, but the exponent here will be something a bit different. Okay, we will take the same example, 10 but raised to power minus 2. If we see here, that was a positive integer, and if we see here the exponent, here we have exponent minus 2. Okay, means a negative integer. Here we know that 10 was to be multiplied twice, which means 10 raised to power 2, 10 was to be multiplied twice. But here 10 is raised to power minus 2. We write it as 1 divided by 10 raised to power 2. Means whenever we have exponent negative integer, we will write it reciprocal of that number. Reciprocal of base we will write if that exponent is in negative. Okay, this I will show here. For example, we have 10 raised to power 2. We write it as 10 multiplied by 10, matlab twice, that is 100. Okay, we write 10 raised to power 1, that's 10, or I can say 100 divided by 10. Okay, 10 raised to power 0, that's I have shown you in the classes that 10 raised to power 0 or any number raised to power 0 is always 1. Okay, or I can write it as 10 by 10. Here it was 100 by 10. Similarly, if we continue, 10 raised to power minus 10 raised to power minus 1 equals to this one divided by 10. Similarly, so on, we will go 10 raised to power minus 2. I will show it on the next page. 10 raised to power minus 2 equals to, what was here, 1 by 10. Means 1 by 10 divided by 10. We are following the same pattern. 100 divided by 10, 10 divided by 10, 1 divided by 10. Here we have 1 divided by 10 divided by 10, or I can write it as 1 by 10 multiplied by reciprocal of this. If I change the divide sign into the multiplication, we have to do the reciprocal of the rest side, means 1 by 10, or I can write it as 1 divided by 10 raised to power 2. That is what I was saying. 10 raised to power minus 2 is the reciprocal of the base raised to power to the positive sign of the exponent. Okay, now our next topic will be laws of exponents. You may have learnt about if we have a non-zero integer, for example, I have a non-zero integer a, if a is raised to power some number and I multiply with this number with another number, a raised to power some natural number, okay, raised to power some natural number, means bases are here same, bases are same, and we were saying that when bases are same, powers should be added. I write it as m plus n. Okay, let us see if this rule, yeah, if this law applies on the negative exponents also. Let's take an example. For example, I was first of all we will take the example of this what we have learned in the previous class. For example, 2 raised to power 3 multiplied by 2 raised to power 2. Here we have the same base 2 and 2. We can write it as 2 and sum of powers. Bases are same, powers are added. That is 3 plus 2 equals to 2. 3 plus 2 is 5. I can write it as 2 raised to power 5. Let's take another example where the exponent is negative. We will take here it. For example, I will take 2 raised to power minus 3 and another non-zero integer, that is 2 raised to power minus 2. Let us see if this law also applies on this where the exponents are negative. Okay, I can write this 2 raised to power minus 3 as 1 reciprocal of the base, means 1 divided by 2 raised to power 3 multiplied by 1 divided by 2 raised to power 2, or 1 multiplied 1 is 1, 2 raised to power 3 multiplied by 2 raised to power 2. Now we will see 1 divided by, here it is the same, a raised to power m multiplied by a raised to power n. Bases I have same and powers should be added, means 2 raised to power 3 plus 2 is 5. Okay, or I can write it as 2 raised to power minus 5. Okay, means this also applies on, if I will do here 2 bases are same, powers are added, matlab minus 3 plus minus 2, or I can write it as 2 minus 3 minus 2, that is 2 raised to power minus 5, one and the same thing. Okay, means laws of exponents applies on both positive exponents and the negative exponents. This was our first law, a raised to power m multiplied by a raised to power n equals to a raised to power m plus n. Now we have the another law, second law, that is if we have the non-zero integer a raised to power m divided by a raised to power n, when bases are same, here we can see bases are same but in the multiplication, but here we see that a and a bases are same but in the division. Then if in division exponents must be subtracted, means a raised to power m minus n. It applies for both. If there is a negative exponent, it will apply on that also. Okay, this was our second law. Third law, a raised to power n whole raised to power, a raised to power m whole raised to power n can be written as a raised to power m into n. For example, if we have a number 2 raised to power 3 whole raised to power 2, we can write it as 2 raised to power 3 into 2, that is 2 raised to power 2, 3 2s are 6, means 2 should be multiplied by 6 times. Okay, this was our third law. Fourth law, if a raised to power m multiplied by b raised to power m, here bases are different and the exponents are the same. Exponents are same, it can be written as a b raised to power m, means one exponent. For example, 3 raised power 2 multiplied by 2 raised power 2. Here exponents are same, bases are different. I can write it as 3 into 2 raised power 2 or 6 raised power 2. Suppose we have to evaluate 3 raised power minus 2. How we can evaluate it? We have seen in previous slides that if the exponent is in the negative, we can write it as reciprocal of base raised power 2. Okay, or I can write it as 1 divided by 3 multiplied by 3, twice multiplication of 3. Okay, or 1 by 3 3s are 9. That is the answer of 3 raised power minus 2. Let's take some more examples. Next example is 1 by 2 raised power minus 5. Okay, we can write it as 1 divided by base is here 1 by 2, means reciprocal of base 1 divided by 1 by 2 raised power 5. Negative exponent becomes positive when we put it in the denominator. Okay, or I can write it as, for simplification, we can write it as 1 divided by 2 raised power 5, or 1. If we change this division into multiplication, we should do the reciprocal of this, means 2 by 1 raised power 5. Okay, or I can say 1 multiplied by 2 is 2 raised power 5 divided by 1, or I can say 2 multiplied by 5 times, 2, 3, 4 and 5, that is 2 2s are 4, 2s are 8, 2s are 16, 2s are 32 will be the answer of this example. Okay, we'll do one more example on the laws. For example, we have to simplify and express the result of the example in the power notation with positive exponent. Okay, for example, our question is minus 4 raised power 5 divided by minus 4 raised power 8. Simply, here we have the exponent in the positive form. We have seen in the laws, if we have a raised power m divided by a raised power n, we write it as bases are same, powers are subtracted when we have the division sign. Okay, here we have the same condition, we have the division sign, and we can write it as bases are same, minus 4 and minus 4, two bases, minus 4 and minus 4, we can write it as minus 4, and powers or exponents should be subtracted, that is 5 minus 8, we can write it as minus 4 raised power we have to subtract 5 from the 8, that is minus 3. Okay, or we can write it as reciprocal of base this raised power 3, or we can further solve it. 1 divided by, we have to multiply minus 4 3 times, minus 4 multiplied by minus 4 multiplied by minus 4, that is 1 divided by 4, 4s are 16, 4s are 64, but minus sign. Okay, that will be the answer of this example. We will solve one more example. If we have to find the value of 3 raised power 0 3 raised power 0 plus 4 raised power minus 1 in the parentheses multiplied by 2 raised power 2. Okay, we have learned that we have the VBODMAS, VBODMAS, vernaculum bracket of division. You know that, multiplication, addition and subtraction. Here we have to solve first this one, that's the braces. Okay, 3 raised power 0 is 1 plus this is negative exponent, so we can represent it as 1 by 4 raised power 1 multiplied by 2 2s are 4, or we have to solve this. 4 raised power 1 is 4, that's, or we can cross multiply it. 4 1s are 4 plus 1 multiplied by 1 1, 4 1s are 4 multiplied by 4, that is 4 plus 1 is 5 divided by 4 multiplied by 4. This 4 and this 4 gets cancelled, hence we have the answer 5. I hope you have learned many things from this video. You will try some more examples on exponents and powers. If there is any problem regarding what we have learned in this lecture, you can WhatsApp me on the given WhatsApp number which I have provided in the first slide, that's here. I can help you there, inshallah. We'll see you next time. Assalamu alaikum warahmatullah.